The first law of thermodynamics is very creatively named the first law of thermodynamics. The first law of thermodynamics states that energy and matter cannot be created nor destroyed, but it can change forms. You know this law as the law of conservation of energy and the law of conservation of matter. The second law of thermodynamics states that an isolated system tends to move toward a state of greater entropy. Hopefully you remember from chemistry that entropy is a measure of the disorder and random motion of particles within a closed system. Okay, now that we've got that down, let's look at some applications of thermodynamics. Let's start with a four-stroke engine. Glue this diagram into your composition book at this time. This diagram shows the four strokes in the most common internal combustion engines. The first stroke is the intake stroke, where fuel-air mixture is drawn into the cylinder. Next is the compression stroke, where the piston moves up and the mixture is compressed. This is followed by the power stroke, where the spark plug sparks, causing a small explosion and forcing the piston down. And finally, the exhaust stroke, where the piston pushes back up, forcing the exhaust gases from the explosion to exit the chamber. These four strokes occur inside every cylinder in the engine of your car all the time when your car is running. Now let's look at it in motion from animatedengines.com. The intake valve opens, you have intake, compression, power, exhaust. Notice that the piston movement is attached by a connecting rod to the crankshaft. This is further connected to the axle of your car, which is attached to the wheels so that your car will go. The next application we're going to look at is thermal expansion. This is the tendency of a substance to change volume as thermal energy is either added or removed. Most substances increase in volume as thermal energy increases, and most substances decrease in volume as thermal energy decreases. However, water is the exception to this due to its unique chemical properties. These two videos give some good examples of thermal expansion. Let's look at some everyday applications of thermal expansion. Have you ever noticed expansion joints on a sidewalk? These allow the sidewalk to expand in the heat and contract in the cold without cracking the concrete. Likewise, for these finger expansion joints on a bridge, the road can expand and contract without causing damage to the road. How about running a jar lid under hot water? This expands the metal ring so that you can get it off more easily.